welcome to section 1.6. We're going to be solving linear inequalities. And so basically this is a extension of section 1.3, and instead of having an equal sign, we'll have an inequality. And so I want to talk kind of about what it looks like. Now we said in section 1.3, an equation started a times a variable x plus another number b, and before we said it could equal a value of c. Well, in this time, we're going to say greater than c. But you don't always have to be greater than. What if it looks like a times a quantity x plus b is less than c? Now, if you're looking at these and going, oh man, I don't remember which is greater than or less than, let's make a note, shall we? This one's greater than, and the one pointing to the left is less than. That's the way I remember it. Pointing to the left is less than. But not only do you have greater than or less than, you also have two additional ones. I could have ax plus b is greater than or equal to a value of c, okay, greater than or equal to, or I could go the opposite direction, ax plus b is less than or equal to c, okay, and so we're going to be looking at four different types. You need to know the difference between these inequalities to ensure success in this section. Now, a compound inequality has two options. So when you're looking at this, and this is super important, we're going to talk about it as we go through. You have an and inequality and an or inequality. Okay? And I'm going to talk about those when we talk about multiple inequalities signs at one time. Okay? Equivalent inequalities, we said equivalent equations had the same answer. So equivalent inequalities also have the same solutions. Let's actually write same correctly. Have the same solutions also. And that just means that if you solve two inequalities and you get the same answer, they're considered equivalent. Okay? Now, let's talk about graphing. We had you graph in Algebra 2, a simple inequality. Here's what cannot happen. I cannot look at a 4 and say, 4 is right in the middle. And if I want it to be less than goes to the left, so it'll go this way. But it could be equal to, so I put a circle and close it in. This is not okay. All right, here's why. I have no idea that you know anything about the numbers around that inequality. Now, let me change this. What is okay is if I put other tick marks in here, which relates it on a good number line so that I know, hey, 4 less than means I'm getting all of these below the 4. And I actually know what type of number those are. So you actually legitimately have to put more numbers than just the one that they give you, or 2 that they give you, or 3 that they give you, okay? Now in this case, the end point is what we call a closed circle, and I didn't write it quite on the line because of my numbers. And the reason it's closed is that it's or equal to. So anytime you have an equal to inequality, again, you close your circle. So let's go in the opposite direction. Somewhere on here, I need to have -2. I'm going to put -3, -4, so I need a -1. And if x is greater than -2, that says from -2 forward, but can it include -2? The answer is no, because it's not equal to, so you open the circle. Okay, so this is an open endpoint, and that occurs when it's not equal to. Okay, so it's just a greater than or just a less than. And so those are the simple ones, and we're trying to model for you exactly what we want our number line to look like. Most of the time, I'm not going to give you specific numbers on the number line. I'm just going to have you draw them. And so you have to be able to relate your endpoint number with the ones around it to show that you know which way is greater than, less than, things like that. Okay, so let's do a compound one. Compound inequalities normally have two different endpoints. And what this says is -3 is less than a number which is less than 1. What that means is on my number line, I have to include both -3 and 1. Okay? So let's take a look. Here's the way I remember how to do that. If x is between, you shade between. Okay, so if x is between the numbers, you shade between the numbers. And then I look at my inequalities to determine if my circle is open or closed. Well, since -3 is just less than, it's going to be open because it's not equal to. And since 1 is not equal to, I open at 1. And because the x is in the middle, I shade in the middle. And there's my inequality. What that says then are the solutions are between -3 and 1. And remember when I told you above, you needed to know the difference between and or? And occurs when you're between two endpoints. Okay, so and occurs when you're in the middle. So the solutions are, if I look at it, I'm going greater than -3, but I'm going less than 1. Okay, and so those are just ideas, but I want you to know the difference between and is a between, so guess is on or is not going to be in the middle. Okay, if you look at or, they're giving you two separate inequalities. So the or is two separate. So as I look at this, I see two numbers. So somewhere I have to have a -1 and a 1. Okay? At -1, I have an open circle, and it points to the left for less than, so I shade to the left for less than. At 1, it's a greater than or equal to. Because it's equal to, I fill it in, and it points to the right, so I shade to the right. Now you'll notice they are going in opposite directions. Opposite directions mean or. I'm going this way or that way is kind of the way I think of it. The solutions are less than -1 or greater than or equal to 1. So kind of keep that in mind. Two parts means an or. One shaded region means an and. Okay, let's keep going. Now, not only are you going to graph them, you're going to solve them. So we're going to go back to section 1.3 for a little bit, and we're going to solve them as if they were an equal sign. However, I've boxed this in for a reason. This is more important than anything else. You will have to switch the direction of your inequality sign if you multiply, I'm just going to shorthand this, or divide by a negative number. And the rule in mathematics is that a negative number affects the inequality sign by flipping its direction. Okay? Now I'm going to solve this like it were an equal sign. I'm just going to continue my inequality down. So here's what I'm going to do. Now in this case, no matter what, I tend to always like my variable on the left, because if my variable's on the left, I understand the graphing of it more. So that's what I'm going to show you. So I'm always going to take my right x value, so in this case the 9x, it's positive, so I'm going to subtract it to move, and I get -5x plus 5 is less than -10. And again, just personal preference, I think it's easier to read when the x is on the left side. So now I'm back, okay, I've got addition, so I'm going to move the addition by subtracting. So -5x is less than -15. When I divide by -5, did you hear my phrase? When I divide by -5, ding, 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 a bell should go off in your head. I'm going to flip my sign. So I'm going to say now instead of x is less than, x is greater than +3. Now the way to check this is to pick a number greater than 3. If you plug it in your inequality and you get a true statement, then your answer is correct. Now if here's my solution, I'm going to graph it. Somewhere I've got to have a 3. It is an open circle because it's just greater than. And my inequality points to the right, so I shade to the right. Okay? Let's try 8, and I'll come back to 7. Okay? See this or sign? Or means in opposite directions. It means 2 parts. So I'm going to draw a line down the middle here a second because I have 2 inequalities to solve. So what I'm going to do is treat each one as if they're separate. In my first inequality, 4x minus 7 is less than or equal to 5. I'm going to add 7. So 4x is less than or equal to 12. And when I divide both sides by 4, the 4 is positive, so my inequality stays the same, and I get that x is less than or equal to 3. I'm going to write or in the middle, and then I'm going to solve my second one. 3x plus 2 is greater than or equal to 23, so I'm going to subtract 2. 3x is greater than or equal to 21. When I divide by 3, x is greater than or equal to 7. Again, the sign does not switch because the 3 was positive. Here is my inequality with an or because they're separate as we go through. Now again, I think you could probably graph this. You would be at 3 with a closed circle shaded to the left, and the second one you would be at 7 with a closed circle shading to the right. Okay. Let's go through the last one, and I'm going to show this one because this one is our different one. This is the one you probably remember the least. This is called a compound inequality, and you'll notice there are 2 inequality signs. Okay. Now, as you're going through, here's what I do. Put your hand over the -7 and the inequality sign. If you look at that, it's back to an original inequality you're used to, and so I'm going to solve this by adding 2. Now the problem is I have an inequality on the left-hand side, so I'm going to move my hand for a second, and I'm going to do the same thing on that side. So -7 plus 2 is -5. I write my inequality. What's left in the middle is a 5x, less than or equal to, and 8 plus 2 makes 10. Now I'm going to do the same thing again. Cover the left side of your inequality with your hand, and I'm going to divide by a positive 5. And I also have to do that on the left-hand side now as well. So -1 is less than x, which is less than or equal to 2. Now this is an and inequality because the x is in the middle. If I draw myself a picture, -1, 0, 1, 2, 3, I know at -1 I have an open circle. At +2 I have a closed circle. And the x is in the middle, so I shade in the middle. This is an and because I'm in between the 2. And so this is, again, maybe something a little different for you. Maybe you look at this and you go, yeah, Ms. Shapanik, I'm fine with this. I did this before, and that's okay too. I just wanted to kind of be aware that you will need to know the difference between an or and an and as we come up on the quiz and the test. Okay? Now, let's flip to the next page. And I actually only want to do the first question with you. Again, you'll notice I'm giving you a ton of extra story problems to do. And we will work on things in classes. But I just really want to give you the gist of how to read them, and then we will discuss more in class. So take a look. You budget $66 a month to spend on your yoga class. The studio itself charges $22 a month plus $5.50 per class. So your $22 charged doesn't matter if you take 5 classes or 15 classes. So that does not need a variable attached to it because it is a constant fee. Any fee is constant. Okay? The $5.50 per class, though, is there. And now they're asking you what's the number of classes. When they ask you the question, that helps define your variable. So I'm going to call X my number of yoga classes. Okay? Because I know that X is tied to classes, we will use the 550 with that. So let's write our inequality. It costs $5.50 per class. Plus, I also get charged just a regular $22 fee no matter what I do. But I only have $66 a month. So somehow the 66 has to play into this. Now, the question is, it can't be an equal sign. Because do I have to spend the $66? No. I mean, I could spend $44 if I wanted. But what is the possible number of classes you could go to? So I want to know what's kind of that maximum number. Well, since 66 is the max I can spend, the total that I pay has to be less than or equal to that 66. I can't go over the 66 or I don't know where my money's coming from. Okay? So here's our inequality. Now what we want to do is solve this. So let's subtract 22. So $5.50 per class has to be less than or equal to 44. When I divide then both sides by 550, my sign stays the same because I'm not dividing by a negative. And what I find is I get this. Now, your mathematics is correct, but if this is the answer you give me, I will mark it wrong. And the reason for that being is it says answer the question. So when you answer the question, what I would say is the maximum number of classes, shorthand this a minute, that I can take each month is 8. Somewhere in there you've told me the month is important. This is supposed to be an N. The month is important. That 8 is my maximum number of classes. And so those are all important keys going through. Story problems do not end in a single mathematical answer. They end in a sentence. Okay? And I am going to harp on that all year, I promise. So that's all I'm going to do in 1/6 for today. Again, we are going to be spending more and more time on this stuff. I'm going to give you practice problems, story problems. I mean, we're going to do it all in class. But I want you at least to have the gist of what 1/6 covers. So that's it. If you get a chance, please start the homework. If you don't, we will be working on things in class.